Thank you for letting me and Bacalhau team to present today. My name is Iryna, and I work for Protocol Labs for the project name Bacalhau. It was on the previous slides just a moment ago, and which is a very funny word, and I haven't been heard about it before I joined the project. So to give a little context, the Protocol Labs, the project is run by Protocol Labs, and our experience is around decentralized peer-to-peer storage technologies. So it's around like Filecoin, IPFS, and significant portion of our team are researchers in crypto, engineers with a scientific background. And a lot of work in the past was done of taking the large data sets and putting them on IPFS or Filecoin at a little no cost. And today I would like to talk about our new project, Bacalhau, and with a funny title, Bringing Mohammed to the Mountain, Compute Over Data, hosted on IPFS or Filecoin. So this is a new way to run any computation on decentralized data. So instead of moving mountains of data to your program, to your computation, instead of it, we move computation to the mountain of data. And just a bit of like as an introduction, there is no need to, there is no limit to any languages or data. Everything is supported as long as you can put it in Docker container, or you can, or WASM, you can run it and use it. So just a quick question. Could you please raise your hands? How many of you have heard of IPFS? And can anyone tell me how many hands have been raised? Sorry, I didn't hear you well.
Half the audience, Iryna.
Half of the audience. Okay, I will quickly go I will quickly talk about what is IPFS and the main advantage of it. So think of IPFS as a distributed system of storing and accessing any files. So so it's a network that connects. It's a public network that connects any storage. So, for example, I have a spare disk at home running. I can just go and plug it into the IPFS network and get some kind of profit out of kind of lending my disk for the storage. So someone will use it. And the main advantage of IPFS, which stands for Interplanetary File System. So it's the main advantage is it's decentralized, so it makes it possible to download the file from many locations that are managed by one organization, right? So, and also it's content-based opposed to location-based. So usually what we do on our computers, we identify by where it's located. So we give address to the file, on which computer it is, or which server it is, which folder it is. And instead of this location-based, IPFS address a file by what's in it, right, by the content. So the content identifier above is a cryptographic hash of the content that at that address, and this hash is unique to this content. And so although it looks like way shorter than original content, it's still like unique. And also this allows you you as a user to verify that you got the content that you asked for. So if there is a bad actor in the network, they can't just give you any content that doesn't match the hash. And even if you don't know the content, if you never saw the hash, there are tools for you to check that hash and content matches each other. And the third advantage it's of IPFS network, it works well for participation and possession. So where many people or organizations possess other people's files and participate in making them available. So it means that if I give you address to even to the server like AWS with where my files live for some research or to process it or for you to verify it. If in certain amount of time I stop using AWS, you cannot reach out to those files, while with IPFS it's always available. So this is quite a famous popular decentralized network. It's been used by a large number of companies. So at this point, we have around 13 exabytes of data, like 13,000 or so petabytes, if this is correct. And so we got feedback from our developers, from engineers and researchers, that it's great, the system is great, but it's hard to play with this because the data is so large. So what we decided to do is to build another layer of network on top of this network, which we call Bacalhau, which is a Portuguese name for code. I will talk about it later, which code stands as acronym for compute over data. And so compute over this network is kind of system for distributed computations over data, and it's a public network. So anyone in the world able to join this network and offer the compute resources, the servers, and also anyone in the world can join this network to connect to this network and ask servers, those kind of participants, to run some work for them. And Bacalhau, so anyone can join it and anyone can request the work that it should be done. And Bacalhau finds the most efficient way for running this computation on data that lives on IPFS, on this interplanetary file system, this decentralized system, where data is public. And so the way that you should think about it is you just like write algorithms to process like large data, and you don't want to deal with moving large pieces of data to some servers to run it, and you have to pay for network, for ingress, for downloading it, which is also very slow. And you want to delegate all this. You want to delegate it to the network that will do it in the most efficient way and coordinate this large data. And it's also self-sustaining marketplace. And so it means that it will find the most efficient way of running it. So why Bacalhau, right? So very large data has a gravity, right? So it's, as I mentioned before, it's very difficult to move this data to your computers or to the servers for computation. A large part of this of this project strategy is how to optimize computation over large data sets, over big data. This copying is expensive. Network is expensive, then storage storage is expensive, so you have to pay for disks as well. and it's long as well, while the job itself is small, right? Although we might write algorithms and it will take for us months to write and might be like lots of lines of code, but in comparison with the data that we run it over, it's usually like our source files or scripts is relatively small, it's incomparably small. And what Bacalhau is offering is a really efficient way of running these jobs over data and allowing scientists and researchers to delegate this job to someone else. So instead of sending data where your source code lives, these large petabytes of data, source code it's possible to send source code to where the data lives, and this is primarily question and idea that behind Bacalhau. And so, as I mentioned before, it's a Portuguese word for code, and code stands for compute over data. And so, again, let's kind of think about like what problem can it solve. It's meant for currently it's already a live beta project which was announced yesterday, and it's network that allows to delegate to these jobs, these algorithms, to run over data that stores in IPFS, where this data is public, and it works really well with IPFS and Filecoin. So it's native extraction of data and writing into IPFS. And we aim to compute any workload and any language. So also abstract way the complexity of a smart contract. So you just do a very short command on your command line to request Bacalhau to run it. And what kind of like jobs can it run? So anything that you can Dockerize, which means anything, any languages, and the WASM as well. So if you're just like WASM is a WebAssembly, is a portable binary code format, right? So it's the main goal of WebAssembly is to enable high performance applications on the web pages, but because there is no specific web assumptions made or features that WebAssembly provides, it means that it's possible to run it on any environment. So that's why quite a lot of languages already have WASM support. So you can basically you can basically build this like WASM binary code format out of your software, out of your program, your algorithm, and send it to the Bacalhau. The inputs is IPFS, or you can also, if you don't use IPFS, you can just specify URL, and Bacalhau will download it for you somewhere. So you don't need to you don't need to worry about storage or efficient computation, and the result of your computation are stored in the files in IPFS or Filecoin, right? So you have your software that's possible to put on a Docker container, and you set the input as a URL, and you just like you run Bacalhau, run this container and this input data with this URL, and it will download the files for you. It will run the computations, and in the most efficient way, the network will find the most efficient way. It will delegate the job to the servers that live near your data, download the result, run the computation, and then output will be provided in IPFS file. And the other advantage is that even if you don't have, like, for example, GPU or any other like latest hardware, Bacalhau has it, and it will run it on there. So you can also specify what hardware you would like to use. So I spoke like to quite a lot of software developers about this project, and they were always like try to compare with solutions that already have, for example, distributed AWS Lambda. So it's so let's kind of compare these two solutions. So it's AWS Lambda is good if you store your data on centralized, like AWS, for example, S3 technology, and use it from there. But again, it's centralized, right? And we are in a kind of decentralized world. So that's also the question. Another benefit is that Bacalhau is so the number that I heard is like 4,000 times cheaper than AWS S3. So it makes sense to compare it again, at least against the costs. And the thing that Lambda is good at, if you don't store your data on AWS, is to kind of where you send the function with the input already in the function. So it's like very small data. And for example, where there is like, for example, product as input and customer as input, and the function will return if the customer is likely to buy this product, for example. So it's not large data sets if you don't store it on AWS. So another question I've been asked, are we trying to build something that Ethereum founders wanted to build in the beginning as a world computer? And we are definitely not trying to build world computer. This is orchestration tool that kind of self-sustaining marketplace, and it's coordinate this like large data for you, and it's placed with this like we are trying to build it for the data sciences and academics that are running quite a lot of heavy computation, data heavy computation. So we would love to hear your feedback. And another kind of comparison with the Ethereum is that Ethereum is a kind of extremely expensive and extremely correct world computer, right? So just to remind you that with Ethereum, when you submit your smart contract, it doesn't run on you just submit it to the network, and when the blockchain accepts your smart contract and list of instructions, it's every node on the network runs the same smart contract, the same computation. So like thousands of nodes. With Bacalhau, you can set up in settings how many nodes you would like to run, how many for verification purposes. So usually it's 3, maximum 10, right? So it's not as expensive. I mean, it just Ethereum and Bacalhau is completely different beasts that are built for different use cases. And so Bacalhau is more like a orchestration tool, and Ethereum, especially now, is quite popular among like DeFi, where you need to run like transactions, verify transactions, like financial transactions. So another tool is a Spark like platform, and Spark main disadvantage for kind of data sciences and researchers is that it has a specific language that you have to rewrite your software. So, and then it will kind of run on. Then it will run. Spark will identify this kind of servers that needs to be run with Bacalhau, it doesn't come with any programming language library. It allows you to submit any job. I mean, any algorithm, any source code or script. It runs everything. And there is like no SDKs needed, so it's quite kind of user experience is 100% more friendly. And now I would like to kind of I would like to share some of the QR codes with documentation. Technical questions are on Slack. So if you would like to try this platform, please go to documentation, and if you have any questions, we are there like 24/7, because team is all around the globe. We'll answer your questions, and we have a very helpful and supportive team of engineers. Also, Bacalhau's Substack is our newsletter. So we currently have quite an interesting and exciting roadmap to support many additional features that we are planning to do in the future, like pipeline support, etc. So please feel free to explore if you're interested. If you run large data sets, if you run computations over large data sets, I would definitely suggest you to explore this platform. Please let me know if you have any questions.
Yeah, Iryna, that was fantastic. We can open it up to the floor right now. Does anybody have any questions for Iryna from Protocol Labs on Bacalhau? Sure. Just a moment. Here you go.
Hi. Great talk. Thanks so much. What do you anticipate some of the first use cases be, or which use cases have you seen sort of so far?
So the project started like 6 months ago, and we already have use cases. We have use cases within like weather company. So just as I should mention, I started this job like 2 weeks ago. So I'm kind of at learning stage at the moment. So what we do, we have a project where we kind of store satellite data and analyze this data for the weather forecast. So this is happening. Also, there is a partnership with a Caltech physics school as well, where we're going to store the data and run computations over that data as well. So there are many kind of research-oriented topics already, also bioinformatics, like genome data sets, and as I mentioned, like geophysics. Quite a lot of wide use cases, and we try to encourage scientists and researchers to try use their use cases on it as well.
That was great. Thanks so much. Please.
So how do you handle data security?
So the data is public, and so the data is public, and if someone is trying to get your data, like steal your data, or what exactly you mean? Because it's a public data that is content.
Let's suppose you wanted to overlay this network on top of a series of hospitals that go on and have patient data inside of them. In the United States, those are protected by something called HIPAA.
Okay.
That's an example of a desire for, The other thing that can happen is if you have an arbitrary computation going there, it could extract the data, put it into another silo, and then sell it, which would not be very nice for the people that own the data.
So for these use cases, we have encryption that is running on top of it, and So the data, some of this data is encrypted, but usually it's like for public, right? So I have to come back to you on this. If you store some like private data, I would suggest that currently we are not allowed, like it's a public data that anyone has access to. If it's we also provide encryption and also trusted execution environments. So kind of soft servers with that contain the trusted execution environment like Intel SDX and AMD. They are working on this part of security, kind of solving security projects and kind of enabling these kind of like use cases for finance and for healthcare. This is very much work in progress at the moment. Currently, it's for public data, but it's a great question.
Yeah, just to add on to that briefly, what I've seen IPFS really good for is open science, these sort of public goods that are out there that don't require that sort of strict regulation. And I think even in the early days of the DeSci movement, people were like, "Is DeSci the same thing as open science?" And in my opinion, open science is sort of a subset of decentralized science, where it is for these public goods that don't have the same sort of restrictions associated with them. It's not going to be for all science, but the more public goods we have out there, I think the better. Any other questions from the audience for Iryna, Protocol Labs, Compute Over Data? Please.
This might be out of scope, but how do you deal if like you need to do like message passing between different computations? So say there's like some dependency and it's not
Good question.
Parallelizable.
So just for kind of we are currently running Code Summit, and there was a presentation on the DAG, so pipelines. This is our work that is happening in progress. Great question, and yeah, we are like quite a lot of new features have been like adding working in progress at the moment. So yeah, it's not available now, but it will be in the very near future.
Got it. How do you imagine you would specify sort of like dependent computations?
So what they showed, it's like a Python script where you just like identify that, okay, output of this kind of function is the input for another one, and then it was like very small, very kind of one line of like pipelines. But in the future, I expect that will I think that use case was also for presentation, that you don't want to show kind of like very large script. So I will also be interested if it's possible to have like more sophisticated DAGs. But I think it's possible that they were just like showing as example like a very simple one.
Cool. Thank you.
Great questions. Thank you.
That was fantastic. Any other questions for Iryna? All right.
Thank you. I'm new to this compute over data concept. Maybe a dumb question. How does the system scale with the number of users? Let's say you have many users trying to run computation over the same piece of data. How would that scale?
So it's a great question. So with IPFS, you don't store data on the same location. You store like you have copies of it. And then if there is so we currently tested only like 4,000 nodes. In the future we will run it more. We will have kind of more nodes than 1,000. And if there are more than kind of many computers want to have run data, many requests that want to run data on the same data set, then the nearest computer, so it's like a queue, right? The nearest computer will get its first, then some kind of server that's a bit like further away will get it second, will start processing second job. And then what's happened is that this kind of like Bacalhau network, it will request the data from IPFS network, and then it's the same queue, right? So whoever got requested first, and then obviously it will be a bit slower if you add like thousands of kind of computations of the same or thousands of requests, but it's more kind of also like DDoS attack. We have to kind of make sure that this is not happening. So I think the main kind of resolution point here that the data stored in several locations. So several locations will kind of distribute the work. So there won't be a bottleneck there.
Thank you.
Feel free. My understanding on distributed data was that it was similar model to torrenting. I don't know if anybody remembers BitTorrent. Correct me if I'm wrong. I'm right. I did it. I remember something I saw on Twitter.
My torrent download speeds get to like 50 megabytes a second. It's pretty good. Any other questions for Iryna? This is a great conversation. I think this is what we're looking for today. Getting
Yeah,
people
it's very
asking
similar to
questions.
a torrent. Yeah.
Well, Iryna, we have a few more minutes left in your talk. Maybe you could go and tell us a little bit about yourself. What you've been doing throughout your career, your history with Web3, and what really attracted you to Protocol Labs. You said you're 2 weeks into the job, right?
Yeah.
Congratulations.
Thank you. Yeah, it's been fantastic. So I was previously I was working in another Web3 layer 1 protocol, which is Mina, which is the lightest blockchain. So they use zero knowledge snarks technology to kind of recursively kind of generates a small blockchain as a proof of all transactions and blocks that happen on it. And it's a great project. It has it's like cryptography heavy. Before that, I was working as a developer relations at permissioned enterprise blockchain at R3, and before that I was engineer for like 8 years, like backend engineer. And before that I was research sciences, and was doing research at in queuing systems and probability theory and signal processing. So yeah, and I really enjoy Protocol Labs because engineers are very, very smart, and it's a great kind of team. It's a great culture, and everyone's super friendly, and I learn a lot. So I'm quite happy. So yeah, I'm also hiring.
Well, that is a fantastic pitch, and I can attest that the Protocol Labs team is fantastic. I'm good friends with David Ronjic over there, who I think is a key part of the Bacalhau efforts. And I think he may have actually been my first boss, technically. It feels like a million years ago now. But your experience is actually quite interesting. Both those other technologies you mentioned, Mina and R3, are super famous projects. I hate to be taking time away from Protocol Labs, and please feel free to share any other questions. Audience, just raise your hand. But I find that like one of the challenging things about our whole space is there really a use case that is super compelling for these really interesting technologies that you mentioned? And I know zero knowledge proofs are really in vogue right now, and there's a lot of interest in what's happening. Were there any efforts that you were involved in at Mina that you'd like to chat through? I gave my little demo earlier of how we're using zero knowledge proofs at WeaveChain to debug a data set that you can't see, but it's still an exploratory effort.
Yeah, Mina is great. the idea is fantastic, and yeah. So the idea with the Mina that you have this like you have a blockchain that is a proof of a blockchain that is 22 kilobytes, and when you run your smart contract, zero knowledge smart contract, they call it like ZK app, on your browser, and only send proof of your computation to the network. So that's why it's quite cheap in comparison with other kind of layer one solutions. And the other advantage with Mina, that data doesn't leave your custody, so it stands on your machine, and so there is no need to kind of to think about where you store, how you store. But obviously, this means that the data cannot be like very large, right? So you're limited to your machine. But in advantage to run Mina, that you can run it on your smartphone because it's so lightweight. So
almost the opposite of the 20 petabyte computations that you guys are tackling
over
at Protocol Labs.
Yeah, exactly. It's like it's kind of you see it's kind of like different use cases, right? One use case that you don't want to share your like small piece of data because it's quite sensitive. For example, as one of the gentlemen mentioned, healthcare, and you just like share with your doctor or with the hospital a proof that you're eligible for some sort of treatment without actually showing your kind of your medical records. And this is like one example, but we all know that medical records are not like usually are not like 22 petabytes of data. So another use case, like for Bacalhau, is data scientists who would love to collaborate and verify some of the research, some of the paper that they read, and they would like to build on top of it. So research on top of that paper. So they know that the data is online on IPFS. They can like easily run computations. They can send their job, their kind of algorithms, assumptions or theories to the Bacalhau to run it over that data. So which is public, and yeah, so it's kind of like completely different use cases. It's been like super exciting to work in both of these organizations, and R3 is developed this permission blockchain, which is called Corda, and it's more the use case is more for the kind of enterprise organizations where you don't want to share your transactions. You don't want to share even like hashes of your transactions with anyone. So obviously you think of like investment banks, etc. So it will store on the transactions. It will store only on the ledgers of the participants in that transaction. So it's because we all know that currently data scientists kind of did some research on the data, on the hashes of the Bitcoin and Ethereum, and it's possible now to identify identity, even if it's private. If it's hashed, everything we can identify where the locations of the person who submitted transaction. So it's not as private as even if it's hashed, and so the use case for the Corda is beyond the private. It's a private financial institutions and organizations.
I love your career progression. You've gone from fully private and permission networks like R3 to some of the zero knowledge stuff at Mina that can be put on public chains, and now promoting public goods and open science at IPFS. It's your path to decentralization, so to speak.
Oh, and, thank you.
You mentioned a really interesting use case that came up actually in the hall earlier as well. Somebody was mentioning, could you go and prove your COVID vaccination to somebody else without revealing any other bit of information. And this is a really classic example that zero knowledge proofs could be used to go and maybe utilize that verifiable credential pattern that I mentioned earlier, where there's some authority like a hospital or even a Walgreens that attests that they gave you that dose, and then you are going to get that presentation and present it to somebody else who can validate it, again, without knowing any other information about you. And what I'm seeing in the space is that we're seeing a lot more tools becoming available to people that want to remain anonymous but still be accredited in some way, shape, or form. So, maybe I could go and I was chatting at the Polygon conference in Paris with somebody who was talking about doing journalism in, countries that are at war, where if you're the person that's actually taking photographs on the ground and presenting information, you're actually putting yourself at risk from, attack from a sovereign state. And, this privacy preserving technology, I think, has a lot of potential to enable people to, be confident that they can participate without having ramifications of their actions.
Yeah, definitely. It's a great example, some great use cases, and also this is a part of that, like protocol apps and IPFS kind of theory. And aim is to break down this like data silos, that it's data, that how much data is being harvested on all of us by big tech, and giving it back to the humanity, giving back to the data science, give data to data scientists, make it public, not data that harvested on people, but kind of humanity, good for humanity data, and making it even allow this kind of allow working together with just hello?
You're still here. Sorry, I was trying to get you on the big screen for everybody. I should have done this moments ago.
Yeah, allowing collaboration between scientists, and allowing more research and more theories to be validated and run on the data. So yeah, it's a next stage of the whole decentralized science, making it possible and easier for scientists to run research, to validate it, to verify it, to collaborate, and to share the data between organizations and between the borders.
You mentioned the use case of a journalist on the ground going on and getting the stuff out there. On the other hand, it turns out if someone wants to go on and break into the defense department, publish all of the secrets that they're never caught, it's a great opportunity to do that too. So all of these things pretty much are value neutral. They're all simply technologies for making this particular kind of data sharing happen. So this will be something that probably comes up pretty quickly, I would imagine, if this stuff you're looking for a use case. This is one somebody would pay for.
Beautifully said on both fronts. It's an exciting time. Well, Iryna, thank you so much for sparking that conversation and for giving that chat today. Let's give her a round of applause.